Okay, I'm continuing with Paul's argument here, and he's saying for the center test mass in the light cone, result for the center test mass, let's put it up here, test mass m, in the light cone, result any object that has effect is in the past. Here's an object where here's the object and the other object. So this is where the object can have effect on the mass at the now point. So your sphere with inner radius r and r plus delta r has a radius in time. That means that any object inside the sphere cannot, as a result, the tugboats cannot connect a line to drag on in the future. The inside of the sphere does not exist from the viewpoint of each point of the sphere. Each point on a sphere calls another point on the sphere as a member of his now. Let's see. Yeah, his now. I'm not sure whether he's talking about, at this point, whether he's talking about Hubble observer now or the coordinate time now, because that would be a shared now. If they're talking about Hubble observers, the now is going like that. And if he's talking about Euclidean, if he's talking about the Minkowski spacetime, now is along right there. I'm not sure whether that clarifies or not. It says, this is why I state in my article that there might be a problem with causality. When you think that you can represent the light cone result as a sphere, like you start with, then you assume that you can have the bidirectional interaction between the sphere and its center. Yeah, the bidirectional interaction would have to be from the sphere to its center would have to involve lines, the particle interacting with the center coming from here, and then interactions from the center going out to the sphere, going up to the events there in the future. Okay, next message from PaulGradenwitz, also from 5 days ago. Responding to me saying, from my perspective, Occam's razor suggests we should not add an additional dimension. But from Paul's perspective, Occam's razor suggests we shouldn't bother with the relativity of simultaneity and Lorentz transformations. And that was at a certain point when I felt like I had some kind of insight into what Paul was saying. I'm not sure if I do or not at this point. He says, from my perspective, Lorentz transformations and relativity of simultaneity are an observed fact for observers in space, but space itself is there over a duration of one event along each world line. These two statements contradict because the relativity of simultaneity requires for space to, you can't have the relativity of simultaneity while simultaneously saying that space only exists for one event on each world line. Again, the relativity of simultaneity, let me see if I can find the animation. Okay, here's the animation as I currently have it. I think I've got too many labels up there, so I'm going to get rid of those. Okay, so here's the diagram. Let's think through what PaulGradenwitz might be saying. From my perspective, Lorentz transformation and relativity simultaneity are an observed fact for observers in space. That's the x comma t. And then he says, but space itself is there for a duration of one event along each world line. And so I think what he's talking about here is the green lines. Each world line of these particles is coming up and down. So I feel like this is a problem with the way Paul describes things. He uses the same word to represent multiple ideas. So here he's talking about space, which is the x-coordinate. And then he's talking about space, which is these green lines. And those green lines are there for a duration of one event along each world line. Each event of space traces its own world line. And then he's talking about the black lines, talking about each event of space, the tracings of the particles being the black lines. What an observer thinks he has to call simultaneous does not change what is simultaneous for space. And so what an observer thinks that he has to call simultaneous, now he's talking about the red lines, does not change what is simultaneous for space. And once again, he's back to the green lines. Euclid did define 3D space, and the 3D space, of course, is what that Euclid defined is well, it's not exactly shown here because this would be Euclidean space for the observer that is traveling with the velocity of the blue lines. So let's pick up the coordinate system when we have the Euclidean coordinate system represented clearly. Whoops, one back. Can't go one back, can I? Close enough. Okay, Euclid did define 3D space. So Euclidean space is these blue lines, or in this coordinate system, it's one dimension of 3D space is those blue lines. Now imagine you have a tetrahedron. It has a base triangle and a top. Okay, we got to do this. A tetrahedron, if I remember right, looks something like this. I could draw dotted lines. Let's see. I guess we just would need one dotted line back there, and then that would be all of the lines of the tetrahedron. And there's another, man, it's hard to draw a tetrahedron. I'll grab up some Google images of tetrahedrons. All right, imagine, okay, it has a base triangle and a top. Another view is that you have one side line below and one side line at the top at a 90-degree angle. Okay, so I kind of see that one over here. Let me just bring it down closer. Okay, so another view is you have one side line at the top and one side line below at a 90-degree angle. Now imagine that view of a tetrahedron and have it go down into a liquid and see how the surface intersection changes. We're going to use a liquid? What are we doing? Optics and refraction? Is that what he's wanting to do here? It says the line changes into an elongated rectangle. Can you do that with refraction? I guess if I put some of this down into a liquid, we could end up having a refraction so that caused that to bend. Maybe. That elongated rectangle gets shorter and wider until it ends as a line at 90-degree angle. Then it disappears. For the 2D surface, that was the set of events changing shapes in time. For the tetrahedron, there was no change in shape over time, but only a change of location. What is missing in the information for the two-dimensional intersection view is the speed of movement of the tetrahedron. The world line assumes a unit length of the 4D shape that moves through 3D space by setting it equal to 1 light second. This reminds me of something that I put on my spoon-fed relativity site some time ago, but I want to look at what it was exactly that I put out there. I don't remember exactly what article it was in. Was it in Lightcone Visuals? There was something kind of similar. This, I think, would form the corners of an octahedron rather than a tetrahedron. But I did show like how strange 3 dimensions is. See how quickly the up and down, left and right, forward and backward are changed. Notice how the apparent angles go from 0 degrees to 180 degrees. And note how the lengths of the lines seem to grow and contract. And then I suggested that the Lorentz transformation does the same thing with a few constraints and differences. Whereas with rotation, left becomes forward and forward becomes down, the future and past axes are different. You cannot move the future past axis to lie in any of the up and down, left, right, forward, backwards planes. Anyway, all this was just to kind of show how the light cone would transform by the Lorentz transformations. But this animation basically represents looking at the same events from different velocities, and this animation represents looking at the same event from at the same object from different directions. I'm going to stop and pause right there and continue in my next video because I don't want to make these much past